Suppose x and y are IID exponential 1. Okay, and what you have to do is find the following. Okay, find the PDF of x plus y. Second, PDF of max xy. Okay, third, expectation of max xy. Okay, remember that when x is exponential 1, then this is the density. Fxx equals e to the power minus x and 0 otherwise. Also figure out the PDF of min xy. Then the expected value of min xy. Okay, so let's start with PDF of x plus y. Okay, let's call that t. Okay, so again, we can first start by finding the CDF of t. Okay, so notice that x and y are both positive random variables. Okay, so the random variable t will also take only positive values. So what we can do is we can restrict our attention to finding the CDF of t when t is positive. Okay, okay, so for t positive, FTT is probability that x plus y is less than or equal to t, right? Okay, and then we can just draw a little picture. Okay, so probability that x plus y is less than or equal to t can be obtained by integrating the joint density of x and y over this region, over this triangle, right? Yes or no? We can obtain the joint density of, we can obtain the we can obtain the CDF of t at t, by integrating the joint density over this triangle. Yes or no? Is that okay? Is that fine? Because that's when x plus y is less than or equal to t, right? Okay. So let us do that. Okay. So notice that the joint density of x and y is e to the power minus x into e to the power minus y. So basically, we just need to do the double integral of e to the power minus x minus y. Okay, with respect to y and with respect to x over this triangle. Okay, over this triangle. So how do you write this triangle? How do you write them as limits? So when you are doing this inner integral, you are holding x fixed. So x is fixed. So this is x. Okay. So when this is x, you will be integrating with respect to y from 0 to t minus x. Right? You'll be integrating with respect to y from 0 to t minus x. And then you'll be integrating the result from 0 to t with respect to x. Right? Yes or no? Is that okay? Is this clear? Okay. Now let us find this integral. Okay, so let's just do it. Please correct me in case there is any mistake. So let's do the inner integral with respect to y. So what is the integral of e to the power minus y? It is minus e to the power minus y, right? Yes, right? So we are going to get what? So substitute in place of y t minus x. Okay, and you will get okay, and then right. Please correct me in case there is any calculation mistake. Let me know. Okay. So this minus x plus x cancels, and you will get right. Yes or no? Okay. Okay. Now let's again do the integral with respect to x. Okay, and we'll get what? The integral of this term is minus e to the power minus x. Okay, and integral of this term is minus x e to the power minus t. Right? Again, let us put in place of x, let's replace this by t. So we are going to get what? Minus e to the power minus t minus t e to the power minus t, and then put 0 there. Okay. So if you want to put 0 there, you're going to get e to the power 0, which is 1. So this is plus 1, right? Okay, and this is 0, right? Because when you put x equal to 0, this becomes 0. So you'll get this, right? Yes or no? Is that okay? So this is a CDF of t, right? I mean, is that clear? Please correct me in case just do the check. Just correct me in case there is any calculation mistake. Okay. Okay. Now, what is the PDF of t? So PDF of t is the derivative of this, right? So let's take the derivative. So derivative of this is e to the power minus t, right? And what about this? So e to the power minus t minus e to the power minus t. Okay. Plus t into e to the power minus t, right? Please check. Is that fine? Okay. So basically this is for t positive, okay, which means basically t into e to the power minus t, right? I mean, this is just going to cancel with this. So we'll be left with this term. Okay. Is that fine? So this is the probability density function of x plus y. Have you all understood this? Any questions? Okay. Now let us figure out the PDF of max xy. Okay, so let h equals max xy. Okay, and let L equals min xy. Okay, so let's find the PDF of h. Again, we can restrict our attention to positive values of h because x and y are both positive random variables, so the max will also be positive. Okay, so for h, so again, first let's figure out the CDF, okay, of h, which is probability that max xy is less than or equal to h. Okay. So notice that the bigger one, bigger of the two, max xy, will be less than or equal to h when both of them are less than or equal to h, right? So what we can do is we can just write it in this manner: probability that x is less than or equal to h, and probability that y is less than or equal to h. And since x and y are independent, we can actually write this probability in this manner also, because we can just take the product of the two, because x and y are independent, so we can write it in this manner. Okay, and since they are identically distributed as well, so we can just write one of them. Okay, so all that you have to do is just square the probability that x is less than or equal to h. That means you just have to find the CDF. Okay, you just have to find the cumulative distribution function of x, okay, and square it. That's all that you have to do. Okay, so how do you figure out the CDF? Well, right? Yes or no? Okay, so we are going to get what? Okay, that's the CDF. Okay, and now in order to figure out the PDF, we'll so this is the CDF. Now in order to figure out the PDF, we can just take the derivative with respect to h. Okay, which is what? Okay, and what is the derivative of this with respect to h? It is, please check this. Is that fine? Is that okay? And now you can figure out expected value of h. So to find the expected value of h, you can just use the PDF, okay, which is integral from 0 to infinity of 2h e to the power minus h minus e to the power minus 2h dh, right? Which is 0 to infinity 2h e to the power minus h dh minus 0 to infinity 2h e to the power minus 2h dh, right? Okay. Now notice that this is 2 times the expectation of exponential one random variable, because h e to the power minus h dh is nothing but, e to the power minus h is the density of exponential one random variable. Okay, so this is nothing but 2 times the expectation of exponential one random variable. Yes or no? Okay, so we are going to get what? 2. This is 2, right? Because expectation of exponential 1 is 1, right? Remember, expectation of exponential n random exponential 1 random variable, all the moments, of exponential 1 random variable are 1 factorial, 2 factorial, 3 factorial. So the first moment is 1 factorial, second moment is 2 factorial, and so on and so forth. So this is just 2 times the first moment of exponential one random variable. And what about this? For this also, what you can do is you can do change of variable. Okay, let 2h be t. Okay, let 2h be t. So you will get what? T e to the power minus t. And since 2h is t, so dh is dt by 2, right? Yes. So we are going to get what? 2 minus half, which is 3 by 2. Is that okay? Is this clear? Have you all understood this? Okay. Okay. Now let us find the PDF of min xy. Okay. So expected value of h is 3 by 2. Again, notice that min xy will also take values between 0 and infinity. Okay. So first we can figure out the CDF. Which is equal to 1 minus the probability that min xy is greater than L, right? And notice that the smaller of the two will be greater than L when both of them are greater than L, right? Okay, so and because these are independent random variables x and y, so we can also write this as Okay, and because they are identically distributed, so we can also write it like this. Okay, which is nothing but, which is equal to 1 minus, please check the calculations, I mean, just in case. Okay, is that fine? Is that okay? Okay. Okay, now let's figure out the PDF. It's the derivative of the CDF. So please check this, right? Is that clear? Okay. And now you can actually figure out the expected value of L. And we just did this, right? We just did this. This is half, right? Is that fine? Okay. And notice that L is exponential too. Okay. Notice that L is exponential too. Okay. So basically, if X and Y are IID exponential 1, then min XY is exponential 2.